Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the January 2024 Pure Mathematics P2 paper from Edexcel International A-Level. And here part A is telling us to sketch the curve with the equation y equals a to the power of negative x plus 4, where a is a constant and a is greater than 1. On your sketch, show the coordinates of the point of intersection of the curve with the y-axis and the equation of the asymptote to the curve. So y equals a to the power of x. If we were to draw the parent function, the normal function a to the power of x, where a is greater than 1, then it will look like an exponential curve where the asymptote would be the x-axis. Okay, and it will have this type of shape. Okay, that would be y equals a to the power of x, an exponential curve. And when x equals 0, y would equal 1 because you'll have a to the power of 0. It will look like this. That's how the parent function would look. So here we have some transformations going on here. If you look at the parent function, you can think of, you've taken the x and you've replaced it by minus x, and then you've added 4 to the whole thing. This is the transformation that's taken place. So there's two things that are happening here. The first thing is it's going to be reflected in the y-axis. It's a horizontal transformation. So basically the x coordinates change their signs. So this will end up going over there. This will stay as it is. It will basically be a reflection of this in the y-axis. So it will look something like this. We'll have this type of shape. Okay, reflection in the y-axis. And then the second thing that's taking place is it's going to be translated by the vector 0, 4. It's going to raise 4 spaces upwards. So this y-intercept is going to end up being 4 spaces high. Is going to go to 5, and the asymptote, which was initially this line over here, which was the x-axis, that was the asymptote, the line it never touched, that would now go up to 4. Okay, it's going up 4 spaces. Okay, so the graph would then look something like this. Okay, it would be something like this. Okay, it will look something like this. So it's going to be reflected in the x-axis first and then raised vertically by 4 units. So instead of going through 0, 1, it's going to go through 0, 5, and the asymptote is going to be y equals 4. Okay, so that would be the sketch. So I'm going to just draw that sketch now neatly. I just wanted to go through the process of the transformations that take place so you understand what's going on. So you'd have your y-axis. I'm going to draw the x-axis very low down because we know that the asymptote is going to be here. Always use a ruler for these sketches. Even though they're sketches, you should always use a ruler. So your asymptote is going to be y equals 4, as you mentioned. It's going to cut through at 5. So I'm going to draw it first. So it's going to go in this direction. It's going to look something like that. Okay, it's going to go through 0, 5. Okay, so the coordinates of the point, so we can put 0, 5 here if you want to as a coordinate, and y equals 4 is the asymptote. This is the x-axis, this is the y-axis. Okay, so that's the 3 marks for this exponential curve, which is reflected in the y-axis and shifted up by 4 units. Okay, so there's the answer to part A. Okay, now for part B. Here we have to use the trapezium rule. It says the table above shows corresponding values of x and y for y equals 3 to the power of negative a half x plus 4. The values of y given to 4 significant figures as appropriate. In this one there was probably a whole number, so it didn't have to. Using the trapezium rule with all the values of y in the table, find approximate value for the integral between -4 and 8.5 of this. Okay, so first of all, when we are using the trapezium rule, what we're doing is, okay, we are taking the area that we have made. So we got our graph, which looks something like this. So we're taking the area under the graph And here it's between -4 all the way up to 8.5. Okay, let me just do that a bit better. Okay, so all the way up to say 8.5. You don't have to draw this at all. I'm just giving you a little idea of where this comes from. Okay, and we're splitting this up into equal intervals. And you see the intervals here seem to be going from -4 to 1.5. That looks like it's going to be 2.5. Another 2.5, another 2.5, another 2.5, another 2.5. So every 2.5 units across. So the width of each of these intervals is 2.5 units. So it's like you're making some trapeziums which are 2.5 units wide, starting from -4. Then you got another one that's -1.5. Okay, and then you got one at 1.5. And then you got one at 3.5. Then one got one at 6. And then you got one at 8.5. So I'll just move that along a bit. Okay, then you'll have one at 8.5. So this is going to carry on going down. So that's 8.5 over here. So you've got all of these trapezium that you've made. So this is -1, -1.5. This is 1, 3.5, and 6 and 8.5. They're supposed to be equally spaced. I'm just doing a little sketch here, right? So they're supposed to be equally spaced, these trapeziums. All right. So basically what we're going to be doing here is we're going to be making a trapezium out of each of these little segments here. Okay, so we're going to basically make a trapezium out of each of these segments. Okay, and we're going to basically find the area of each of these trapeziums. So you have 1, 2, that's 1, 2, 3, 4, 5 trapeziums. 1, 2, 3, 4, 5 trapeziums. So the number of ordinates is actually different from the number of trapeziums. Okay, I'm going to make this make it clear that this is the axis. So I'll just change this style to make it look like this. Okay, and the same with this one. Okay, so that's the axis, but these are the actual trapeziums. Okay, just to make it clear. All right, so you have here 1, 2, 3, 4, 5 trapeziums, and you have here 1, 2, 3, 4, 5, 6 ordinates. So there's 5 trapeziums, there's 6 lines. Okay, so a lot of people get confused about how to use a trapezium rule. It's very, very simple. Okay, the width of each of the trapezium of these, the width of each of these intervals is the height of the trapezium. We know that the area of a trapezium is given by h/2 times the sum of the parallel sides. And if you look in the formula sheet for the trapezium rule, you will have basically, you know, it will say h/2, okay, and they'll say h is equal to b minus a/2. Don't have to worry about any of that here, okay? H is simply this gap between these. That's what the h is. So you're going to have the h is going to be, in this case, it's going to be 2.5. Okay, that's the gap in this case. All right, each of these are 2.5 wide. Okay, the gap between each of these is 2.5. So that's like the width of each trapezium. Okay, and then you're going to have basically that divided by 2. So it's h/2. That's that part. Then you have to have the sum of the parallel sides of each of these trapeziums. So if you look at the first trapezium, the y value, which is represented by this, is the length of that parallel side of this first trapezium. And the y value of this ordinate here, -1.5, is the height of this parallel side. So this is like, you know, 13, and this is like 6.280. So if we were to find the area of this trapezium on its own, it will be 2.5/2 times 13 plus 6.280. Right? However, we want to add together all of these trapeziums at once. So the formula that the formula sheet gives you is basically going to do that. So you'll notice that this line is in both the first and the second trapezium. So this 6.280 is going to be used in the formula for both of these, for this trapezium and for that trapezium, because it's like the second line of this trapezium, but the first line of the second trapezium. All right, and same with this. This is the first line of this trapezium, but the first line of this trapezium, and so on and so forth. The only ones that will be used once are this first and the last one. Okay, they will be used once. So I'm going to write 13 plus 4.009 plus, those are the only ones that are going to be used once. And the ones in between are going to be used twice. So you do 2 times the sum of all of those. Okay, so you're going to 2 times 6.280 plus 4.577 plus 4.146 plus 4.037. Okay, and those together and multiplied by 2 will give you basically the sum of all these, but used twice, once for the first trapezium and second for the next trapezium next to it, all the way through. Okay, and the first and the last lines are used just once because there's no trapezium before this and there's no trapezium after that. Okay, so that's how those are used. Those are the y values. And when we calculate this, it will give us our answer, which we will then round to 2 significant figures as the question tells us to. So we're going to have here, let me just put it somewhere where I can see. I'm going to actually go back up here in case I have written down some of the numbers wrong, and I will use the actual numbers from the table, okay, just to make sure I don't make a silly mistake there. So I know that I'm going to have 2.5 divided by 2, okay, times, then I have 13 plus 4.009. Be careful when you're typing that you don't make a mistake. Plus, then I have 2 times, and I have to open a new bracket. I'm going to add these together. I'm going to add these ones together. So I have 6.280, 6.280 plus, okay, 4.577, 4.577 plus 4.146, 4.146. So make sure I've done it right. And then finally plus 4.037. Close the inner. Hold on, that's supposed to say 4. And I pressed 1. Be careful. So that's supposed to be 4.037. Okay, so I'm going to close the inner bracket and the outer bracket. Oops. I'll close those 2 brackets, press equals, and I end up with the answer as, I'll write it as this decimal first. Okay, which is, what's happened to my pen? Okay, which is 55,000, what was it? 55,089 over 800. Okay, and we have to round it to 2 significant figures. So that gives me 68.86125, 68.86125, but they want 2 significant figures. So that's going to be 69 square units. So that's the answer to part B of question number 4, which is all about the trapezium rule. Okay, now for part C. It says, using the answer to part B, find an approximate value for, and they've given you these 2 questions. Now here's the answer to part B. We found that this, using the trapezium rule, gave us approximate value, which I've put in its more exact form. Now, if you notice, what we have to find the approximate value for, they look quite similar to the actual question that we had to answer earlier. So the first question, we got to find an approximate value for the integral of of 3 to the power of negative half x, okay, between the values of 8.5 and minus 4, okay, with respect to x. Now, if you compare that to what we have here, okay, what we have here can be split up into 2 parts. I can split this up into 2 parts. I can say this is the same as 8.5 minus 4, and I can write this as 3 to the power of minus a half x plus the integral of 8.5 minus 4 of 4 with respect to x. So basically, what I can do is this is going to be the same as my answer to part B, minus the integral of 4 with respect to x between minus 4 and 8.5. Okay, it's going to be the same as the answer to part B, which is going to be all of this minus that. Because if I take away from this, the integral of between minus 4 and 8.5 of 4 with respect to x. These two will cancel out, leaving me with, okay, what they're asking us to find. So all I have to do is take my answer to part B and take away the integral of this. Okay, so I can find the integral of this in different ways. Basically, one of the ways I can do it is to just basically find the area of between minus 4 and 8.5 of this rectangle. That's y equals 4. That's the line y equals 4. It's like going to be a rectangular shape, isn't it? So it's going to be, this is going to be 12.5, and this is going to be 4. So this, the area of this shape is 12.5 times 4. So I can just take the area answer to part A, which is 55,089 over 800, minus, I'll have 12.5 times 4, and that will give you my answer. Or alternatively, I can take this and integrate it. So I can integrate 4 with respect to x, which will give me 4x, okay, between 8.5 and 4. So it's the same as doing 4 times, the integral of 4 times 8.5 and 4 into x. So you can do, there's going to be basically 8.5 and minus 4, not 4, minus 4, okay, because it's to minus 4. So it's like the same as doing 4 times 8.5 minus 4. 4 times 8.5 minus 4, which is the same thing as I wrote there, 4.5 times 12. So in the end, you end up with this as your answer. So we can take the answer that we got from part A, which is actually still here, minus 12.5 times 4. And that should give me the answer, which is 18.86125, 18.86125, which we can write to 3SF. It doesn't tell us how to round it, does it? No, so it's best to write it to 3SF, 18.9 square units. Okay, so that we can say is the answer. In fact, they didn't ask us to write it as an area, so we didn't have to put even square units. It didn't say find the area, it just says find the value of this integral. So you don't have to put square units, that's fine. Okay, and for part 2, we got to find the integral of this is actually what we found. This is exactly the same as what we found. Okay, but then add to it this other integral. Now, we'll notice something with the transformations that we made about this other question. So I have 3 to the power of minus a half x plus 4 with respect to x. Now I know the value of this, but we got to do this plus the integral, and it's like the limits have been swapped around from 4 to negative 8.5 of 3 to the power of a half x plus 4 with respect to x. So it's the same thing as this, except with a minus sign, with the plus sign. So what we can understand here is, if we look at the graph of what we drew earlier, of what we drew on the last page, it would look something like this, as we described. It was like reflected in the y-axis and shifted up 4 units, so it went something like this. Okay, and that's how the graph looks like, and we drew it between minus 4 and 8.5. Okay, now the other graph is like, it's the same graph, except it hasn't been reflected in the y-axis. It's going to be basically the mirror image of this, okay, but starting from negative 8.5 and ending at 4. So it's going to be having the same asymptote, but it's going to go like this. So basically, these two areas will be the same. This area and this area, well, they'll have exactly the same area. Okay, it's just a mirror image of this, but they have exactly the same area. So we can say that this is the same as 2 times the answer to part B. It's just the same, because this is the answer to part B, and this is, you have to add the same area. It's going to be exactly the same area. It's just a mirror image of this. In terms of the limits and everything, you can see you're going to get exactly the same area. So you just take your answer to part B and you multiply it by 2. So it's 2 times 55,089 over 800. 2 times 55,089 over 800. And that should be the answer to part B. So we go back to this answer here and we multiply it by 2. And we get our answer 137.7225. 137.7225. to 3SF, that's 138. And there's the answer to part 2. Okay, so that concludes this question. So they don't expect you to use the trapezium rule all over again. All right, they expect you to, you wouldn't use the trapezium rule for this or for that. You would use the answer to part A, and you would think about how you can adjust what you found, okay, to give you the area that you need. Okay, so we just have to look at the relationship between these. This is basically the same as this area takeaway. This basically is the rectangle underneath it. Okay, if you think about what this was, it was like this. So it's basically the area of this is basically as if this is going up to the x-axis only. So you're taking away the area of this rectangle that's underneath it, basically. You can think of it like this, and here you can think of these two areas are the same. So when you add them together, you get the answer to this. So it's just 2 times the answer to part B. And that concludes this question. Question number 4 from the January 2024 paper. A typical type of trapezium rule type of question, and also a bit about how to sketch graphs. So you can watch other questions from this paper by clicking on the link that will appear over here. You can watch questions dealing with exponentials. I'll put that also in that chapter as well, so that we can learn about the sketching of exponential graphs. Also in the playlist, which has got to do with the trapezium rule, which is quite a very common question in P2. And you can subscribe to the channel by clicking on this link. Thank you for watching, and see you soon.